All right, ladies and gentlemen, day one of our circles unit. Let's make sure that you have your circle formula book. If you don't have that, go back and make one. So watch the video previously. If you do have it, great. Let's get it out and get it ready to start getting filled in. So what is a circle? The circle is a set of all points equidistant, means the same distance, from a given point called the center. In this case, in my picture, it is called circle C because it's denoted based on the circle letter. In a circle, we have a radius, which is a segment that has one endpoint on the center of the circle and the other on the other side of the circle. So for example, CY is a radius. The diameter is a segment that contains the center of the circle and has both endpoints on the circle. So XZ is considered a diameter. A central angle, which is something that I'd like to just highlight, and I would underline it or star it or do something. Maybe we'll put it in our book here in a little while. Central angle is an angle whose vertex is at the center of the circle. So angle YCZ is a central angle. And then something that's kind of one of the moments, but again, we have to state it, is circles. Congruent circles are circles that have the same radii. So if my radius is this much and my radius is this much, my other circles, they have to be the same. Okay, some vocabulary word is an arc. An arc is a part of a circle and it's measured in degrees. So arc AB. A semicircle is half of a circle, measures 180 degrees. And then when we talk about arcs, we have two different types. We have a minor and a major. A minor, well, think about it. What does a minor sound like if you have a minor accident versus a major accident? Minor's smaller, major's larger. So a minor arc is smaller than a semicircle, and that's that key part there, and is measured in its corresponding central angle. So that's a cool part that I also like. So it follows the same degree as its central angle. A minor arc is larger than a semicircle, and it's 360 minus the other central arc. So what we're going to do, and I'm going to see how this works today because I haven't tried it yet, is I'm going to blow up my face for a moment, and I'm going to show you what you need to put in your formula book. So when you see it, go ahead and pause and get that in. And our formula book has two pieces. We have the top part, notice where my flap is, and we have the bottom part. So here's the top part. We have some vocab. An arc. Arc is part of a circle. Semicircle is half a circle, and a major arc. Minor arc is less than, and major is greater. So go ahead and pause and get that information in. Okay. Next, we're going to write some examples and what they look like. So that's a minor arc of AB, semicircle of CD, and a major arc of EFG. If you notice with that, my minor arc has 2 letters, my semicircle has 2 letters, my major arc has 3 letters. Maybe where's my mouse? Okay. There we go. So now we're going to do some practice problems. We're going to identify the following things in the 2 circles. So for 1, 2, and 3, yes, 1, 2, and 3, we're going to use this circle. In 4, 5, 6, 7, 8, 9, 10, which my face is covering, we will use the second circle. Ooh. So, minor arcs. Minor arcs are, again, smaller than 180 and use at least 2 letters. Use only 2 letters. So one example could be from A to B. So we're going to say AB. And I'm going to delete that. So we're going to have lots and lots of colors. Helps to flicked it with my finger. AB, we could have BE. We could have ED. And we could have DA. Now, I can also go the other way. I could have, instead of A to B, I could have B to A, but it's the exact same arc. It's just in a different letter format. So again, same thing, just slightly different. Next, we're going to talk about a major arc. Major arcs are more than 180. So if I see, say, A to E is a semicircle, I have to be bigger than that. So I'm going to say A to E to D. Or I could have said, where's my mouse? A to B to D. I just need to hit one of those letters in the middle. Or I could have gone backwards and gone D to E to A or D to B to A. It's the same arc. Next, I could see the B to E to A. I have E to D to B. And then D to A to E. And that's my last major arc groupage. Semicircle. Well, we've got ABE. We've got BED. Bed. We've got DAB. Hey, we're going to dab today. And then I've got A. Wait a minute, which one am I missing? Oh, I'm sorry, I missed the E one. The one that starts with E. So then I've got E to D to A. Okay. Determine the measure of each arc. Now I said a central angle is equal to the arc across from it. We said that on slide 2. 1, 2. So if you notice, in my circle O, angle COB is 32 degrees. So that means that arc CB has to also be 32 degrees. I have arc CD. I'm pointing with my finger, you can't even see it. Arc CD is 58 degrees. So that means angle DOC has to also be 58 degrees. And I'm going to write that in there because I feel like that's going to be some information I want. What else can we see? Well, I see that ADC is a semicircle. So that's 180 degrees. And then likely, like vice versa, excuse me, A to B to C is also a semicircle, so it's also 180 degrees. Oh, and then there's probably going to be some addition here in a moment. All right, let's go ahead and talk about the measure of these things now. BC, well, we just said that was 32. B to D. Okay, so B to D, it's only got 2 letters, so it has to be that minor. So it's going to be that 32 plus 58, which is 90. Then it wants to know A to B to C. Well, hey, we already said that was a semicircle, that's 180. B to A, or A to B. Well, if A to B to C, that whole piece is 180, and this little chunk is 32, I'm going to take 180 minus 32, which is going to give me 148. Then it wants to know C to D to A, which again is that semicircle. asking for A to D. So again, we know this big guy is the semicircle, so it's 180 degrees. I have this little piece of 58, so 180 minus 58, which is going to give me 122. Lastly, it wants to know how much is bad, B to A to D. Well, if we know this piece here is 90 and a whole circle is 360, we're going to take 360 minus 90, which is going to give me 270. Next, we're going to talk about circumference. Circumference is the distance on the round circle. So circumference of a circle is pi times the diameter, or 2 pi radius. So there's two different formulas that are the exact same thing. So just mean the same thing, different ways of writing it. So we're going to get out our handy dandy formula book again. So we're going to flip to the next page, and we're going to have circumference. And then down below, we're going to have some examples. And I'm going to try and cover up the answers so that you guys can work them through when we work them through. So essentially, I picked two of the three problems that you see below on your notes, and I just drew them. Not very well, but I drew them. All right, we're going to go ahead and determine the circumference of the following. So let's get our handy dandy calculator out. Now, circumference is 2 pi r or pi d. So we have to take a look at what information we're given. So in problem 11, we're given the diameter. So I'm just going to take the diameter of 23 times my pi. So I'm going to type it just like that in my calculator. And I'm getting a phone call. I will be back.